As we begin working on these exercises, this is where knowing your trig values and having studied them and having them memorized will make your life so much easier. So before we get started on these exercises then, I made another sheet over here where we just review how to remember our sine and cosine of our 30, 45, 60, our most common angles. And it says to answer in radians. I know I personally think better in degrees. But as I've mentioned before, all of calculus is done in radians for reasons that your Calc 1 teacher will explain to you. And so you're asked in this exercise to answer in radians. So I have the radian equivalent over here. So anyway, the quick rule that you are supposed to remember is if you start with sine of 30, right, which is a half. But if you can remember radical 1 over 2, now radical 1 is just 1, radical 1 over 2, radical 2 over 2, radical 3 over 2. Okay, it goes in order, and then this comes back up the other way. Radical 1 over 2, radical 2 over 2, and radical 3 over 2. Okay, and then for tan, tangent is sine divided by cosine, so tangent of 45 or pi over 4 is 1. Sine divided by cosine, right? So flip cosine. So tan of 30 is 1 over radical 3, or sometimes that's written as radical 3 over 3 if we rationalize. And then if I go the other way, this flip the half, right? The 2's will cancel and I'll get radical 3. All right, so this will help us out in this exercise. And then I have just a little refresher here of the unit circle, right? That remember that x is cosine, y is sine, right? So the cosine of 0 is 1, sine of 0 is 0, right? And then this is 90 degrees. This would be negative 90 degrees going this way. All right, so this will help us. So back to the exercises. So let's take a look at a few together, and then I'll have you pause the video and try a few on your own. But remember what inverse sine means, okay? If I'm working with the sine function, all right, like y equals sine x, remember that what I input, the input here is an angle. All right, I input an angle and then I output some value between 0 and, or I'm not 0 to 1, negative 1 to 1. Okay, so some value like a half or radical 3 over 2. All right, so remember what happens here. I switch input and output. Okay, so my output has to be the value of the angle. All right, and I input some value between negative 1 and 1. And so I'm asking myself, what is the angle whose sine is 1? Okay, so in letter A, I am asking you to find the angle whose sine is 1. And I hope you recognize that that's a quadrantal angle. All right, and if you need to refer to the unit circle, you can. So when is sine, which is y, 1? Right, y is 1 here. The angle here is pi over 2. All right, so that would be pi over 2. All right, then the next one asks us, find the angle whose cosine is 0. All right, and then next I'm going to be finding an angle whose tangent is radical 3. Luckily, that's right on my chart. All right, so let's go to the next page and get the answers for B and for C. Okay, so I'm finding the angle whose cosine, whose x is 0. Now, I have a choice here, right? It happens twice. It happens at pi over 2, and then it happens again at negative pi over 2. That's where I have to remember what my restrictions are, right? What were the domain restrictions on those original 6 trig functions? Because then that tells me what kind of output I can possibly have. Okay, and so remember, cosine was restricted from 0 to pi, which means I can only take then output of the inverse cosine function. The output has to be between 0 and pi. Therefore, I can't use this one, and I have to use this one because there's only one possible answer. That's what my domain restrictions did for me. There's only one possible answer, which is what allows these inverse trig functions, keyword function, that is what allows them to be a function, right? Only one output for every input. And then here's where I see the radical 3 on my chart. Okay, so that happens at 60 degrees or pi over 3 radians. So I come back here and answer pi over 2 and then pi over 3. Okay, so please pause the video and try 6. Okay, there's the answer to number 6. So the angle whose sine is 0 is 0. The angle, again, if I'm looking at the unit circle, the angle whose cosine is -1. Actually, I didn't write it on here, but whose x is -1 is pi, right? And then finally, tangent of 0 is also 0 since tangent is sine over cosine. All right, so let's do number 7 together. Okay, so I know the answer to both of these is some version of 45 degrees, actually for all of these, okay, because sine and cosine of 45 degrees is radical 2 over 2, and then tangent of 45 degrees is 1. Now the issue that I have here are the different quadrants. Okay, so remember, sine has a restriction of quadrants 1 and 4. So does tan. Okay, which means the output that I can get from the inverse trig function has to be in quadrants 1 and 4. Right, and cosine has been restricted to quadrants 1 and 2, which means that the output that I'm going to get from my inverse cosine function has to be either a first or second quadrant angle. So both sine and tan are positive in the first quadrant, negative in the fourth quadrant. And so here's what's tricky. Okay, so I have to have a 45-degree reference angle. Right, so here's my 45-degree reference angle. I'm in the fourth quadrant. Now, do I want the angle -45 degrees, or do I want the angle 315 degrees? Right, which one do I take, or doesn't it matter? Could I give either answer? Okay, so think about that for a minute. Which answer should I be giving in letter A? Actually, A and C are going to have the same answer. Okay, and it does matter which one I take, and that is because the domain was restricted from -pi over 2 to pi over 2, okay, for sine, right? That means that my range for inverse sine is between -pi over 2 and pi over 2. 315 degrees is not part of that range. Okay, so I have to take the negative 45 degrees. Negative 45 degrees is in that range. Remember, 45 degrees is pi over 4. So I would answer with negative pi over 4. And then same thing over here. Okay, so I have to give an answer that's within this range. Now remember, cosine was restricted from 0 to pi, right? So then cosine would be negative in the second quadrant. So I need a second quadrant angle that has that 45-degree reference angle. Okay, so what is this angle here? Okay, and so I would do 180 minus 45 to get 135 degrees. And you're supposed to be answering in radians. Okay, so I can take 135 degrees and I can change it into radians by multiplying it by 1 in the form of pi over 180. And if I divide numerator and denominator by 3, that would simplify to 3 pi over 4. All right, for letter B. All right, so this is the answer right here. Okay, so please pause the video. Go back to this page here with the charts, right, to help you answer A, B, and C here. But again, think about what quadrant you would have to be in. All right, so pause the video and try number 8. All right, for 8A, that would be 60 degrees. 60 degrees, or I would have a 60-degree reference angle, which is pi over 3, but I left this here because we have to be in the fourth quadrant. We have to have a 60-degree reference angle in the fourth quadrant. So then I want to know, do I use negative 60 or do I use positive 300 for my fourth quadrant angle, or does it not matter? All right, and it does matter because I have to take the angle that's in this range, which would be the negative 60. All right, so negative 60 is negative pi over 3. All right, I cannot use 300. That would be incorrect. And again, this is kind of nice, just like in the last one. These two have the exact same answer. All right, but where cosine is negative, I have to be in the second quadrant. Again, I'm using a 60-degree reference angle. All right, so I'm finding the angle whose cosine is negative 1/2. It would have to be 120 degrees. It would have to have a 60-degree reference angle, and 120 degrees, when I change that to radians by multiplying by pi over 180, and I simplify that down, that is, I can cancel these, divide both by 6, so that is 2 pi over 3. Okay, so let's move on to some more exercises. The next set of exercises I'm going to go kind of quickly through because this is what you did in high school. Okay, in high school, you had to find missing angles in triangles and using inverse trig. So what you would do in this first triangle is you would say, well, the opposite over the hypotenuse in reference to this angle, right? So we're using our SOHCAHTOA. Okay, so the opposite over hypotenuse is 6 over 10. So that tells me that sine theta is 6 over 10. So what that means is that the inverse sine inverse, or arc sine of 6 over 10 would equal the angle. Okay, so you just take out your calculator. Inverse sine is the key. I know on mine I have to hit green first. Rather than yellow gives me sine, green gives me inverse sine. Okay, so whatever key that is on your calculator. And I got for theta, when I did it, and it said round to the 1 decimal place. So I got 36.9 degrees. Okay, so pause the video, try number 18. Right, you should have used tangent, right? Because this is my hypotenuse over here. They have the right angle in a different position here than we are usually. We're not really used to seeing triangles oriented that way, but hypotenuse is what's across from the right angle. So I have opposite over adjacent being 7 over 18. So I would do inverse tan of 7 divided by 18, and that would give me the angle, which results in, I got 21.3 degrees. Okay, so like I said, you should remember this pretty well from high school. All right, next section down here. So let's take a look at finding the cosine of the inverse sine of 4/5. All right, and so the way that we're going to do all of these problems here, 29 through 34, and then the couple down here below, is we're going to be drawing a triangle. Okay, so if I illustrated this with a triangle, I'm just going to draw in the middle of these examples. All right, so here's my triangle. And this is my theta. Okay, what this part means is that the sine of some angle theta is 4 over 5, or 4 over 5. All right, so according to SOHCAHTOA, sine is opposite over hypotenuse. Okay, so I know that sine theta equals 5 over 4. Okay, that's what I'm told here when I'm given inverse sine 4 over 5, right? And I know that that's some angle. All right, so now I want to find the cosine of this same angle. So I want to find cosine of theta, and I know that cosine is adjacent over hypotenuse, and I'm missing my adjacent side, but I can solve that very easily with Pythagorean theorem. Or if you know your Pythagorean triples, right? 3, 4, 5 is known as a Pythagorean triple. That'll save you a little bit of work, right? Otherwise, you'll be doing 4 squared, right, plus x squared equals 5 squared, right? And you'll be solving for x, okay? I assume people can do that without any problem, okay? But this would be 3. Therefore, the cosine of this angle would equal 3/5. That would be my final answer here. Right? If I were working through exercise 30, right? Exercise 30 says the angle whose tangent is 4 over 3. So the angle whose opposite over hypotenuse is 4 over 3. Well, how nice. This is the exact same triangle. All right, so 29 and 30 are actually the exact same problem, right? Both 29 and 30 have an answer of 3/5. All right, so let's try together. Let's do 32, and then I'll have you pause the video and turn you loose on an example. So for 32, I know that the cosine of some angle, all right, so that's what I'm given here, that the cosine of some angle, theta, so if I call my angle theta, the adjacent over hypotenuse of some angle is 7/25. Let's see if I can get a better, let's do this instead of me drawing a pathetic looking triangle. There we go. Okay, so I've got my right angle, so I'll call this theta. All right, there's my right angle. So I know that for theta, adjacent over hypotenuse is 7/25. Then I want to find the cosecant. So remember, if sine is opposite over hypotenuse, then cosecant is the reciprocal of sine. Okay, so cosecant is hypotenuse over opposite. So I have to find that opposite side. Okay, so again, Pythagorean theorem is going to let me do this. Okay, so I would have x squared plus 7 squared, which is 49, equals 25 squared, which is 625. Okay, and then if I do 625, take away 49, I get 576. Is that right? Yep, 576. And then I take the square root of both sides, and I get x equals 24 with the Pythagorean theorem. So x is 24, which means that my hypotenuse over the opposite is, hypotenuse is 25 over the opposite, which is 24, is my final answer for 32. All right, so you go ahead and try 31. Okay, so for 31, the sine of theta is 12 over 13. Okay, so sine is opposite over hypotenuse. And then I want to find the secant. So cosine is adjacent over hypotenuse, which means its reciprocal secant is hypotenuse over adjacent. And when I use the Pythagorean theorem, my missing side here is 5, right? After I do a squared plus b squared equals c squared. Therefore, the final answer here for hypotenuse over adjacent would be 13 over 5. That's my final answer. Okay, so last exercises to try. All right. Sorry, bear with me here while I erase for a minute. It doesn't let me erase anything I did in text box. That's good to know. So anyway, I am applying, sorry, now I feel like my workspace is a mess. I'm doing this problem that I'm highlighting here in green. Okay, and I'm ignoring all this stuff. Okay, so I want to find the tangent of the arc sine of x over 2. Right, so instead of having actual numbers, I have a variable. That really doesn't change anything in the problem. All right, so again, I should know, according to this problem, that sine of my angle theta would have to equal x over 2. Okay, so sine is opposite over hypotenuse. And then I want to find tan, which is opposite over adjacent. Okay, so I've got my opposite side x. I need to find the adjacent side. So I'll call it, I don't know, I'll just call it Q. Okay, and so according to the Pythagorean theorem, for me to solve for Q, I need to do, let's see, I'm going to extend my page a little. And I'm going to open another text box and do x squared plus q squared equals 4. Right? And I'm solving for q. Okay, so q squared would have to be 4 minus x squared. Okay, and then I'd have to take the square root of both sides. Okay, so q squared, or q, is going to end up equaling radical 4 minus x squared. Okay, so now when I want to take the tangent of this, right, the tangent of that ends up equaling opposite, which is x, over adjacent, which is radical 4 minus x squared. All right, so that would be my final answer. So please pause the video, try this last example, and then we're done. All right, so adjacent. Oh, I'm recording. I'll talk to you in a minute. All right, so this would be cosine of theta equals x. All right, cosine is adjacent over hypotenuse, so this is a 1. And then if you would use the Pythagorean theorem, you should have found this third side to be 1 square root of 1 minus x squared. Okay, that would be the opposite side. And now if I want to find sine, sine is opposite over hypotenuse. All right, so the answer to this is opposite over hypotenuse. Well, the hypotenuse is just 1. All right, so I mean, I don't have to put it. So this would be my answer.